Okay, this is a solution to a very difficult exponential growth question, which will be relevant for AS level maths and maybe even A2 level maths. So it says a man buys meat and puts it in the refrigerator. It contains low levels of bacteria, but these bacteria could potentially cause food poisoning if allowed to multiply to a certain level. The number of bacteria can be approximated using the equation n is equal to n0 e to the pt, where n0 is the initial number of bacteria. And that is a common way of saying the initial thing, so N0 or T0, whatever. So N0 is the initial number of bacteria, P is a constant, and T is a time in hours. When it is purchased, the meat contains 10,000 bacteria. Given that the number doubles after 2 days, show that P is equal to ln of 2 over 48. Okay, the question goes on, but this is the first question. So instead of reading ahead, we're going to just do the first part and then we'll go on to the next bit. It doesn't do you any good really reading on in the question for this type of thing. It just sort of panics you. Okay, so the first thing we do is write down the equation, which was n is equal to n0 e to the pt, and that's where n0 is the initial amount of bacteria. So n0 is equal to 10,000 because there was 10,000 bacteria. And T is a number of hours. It says, given that this number doubles after 2 days, so in 2 days, 1 day is 24 hours, so 2 days would be 48 hours. And then if it doubles, that means n is going to be equal to, and it's going to be double of 10,000, so it's going to be 20,000. So we're going to sub both of those things in, so that means you put in 20,000 instead of your n is equal to 10,000 times e to the 48p, and then what we're going to do is just all it is from now on in is just a rearranging the formula question. So let's have a look at what's going on. We want to end up with p is equal to something, so that's where we're trying to get to. So in this equation, 20,000 is equal to 10,000 e to the 48p. First thing is your p is being multiplied by 48. Next thing is, then you're doing e to the power of that. Next thing is you're multiplying by 10,000. So that's the first thing we reverse. So the reverse of multiplying by 10,000 is dividing by 10,000. So that's just 20,000 divided by our 10,000 will just be equal to e to the 48p. And then just tidy up. That's just going to be 2 is equal to e to the 48p. And then let's go through that again. First thing was happening to our p was it was being multiplied by 48, and then you're doing e to the power of that. The inverse or the reverse of e to the power of something is ln. So take ln of both sides. You're going to have ln of 2 is equal to just, and ln and e cancel each other out. So it just gives you 48p. So 48p equals ln of 2, which means 1p is equal to 1 over 48 times ln of 2. Or I think that they write that as, they wrote that as ln of 2 all over 48. And you can see, happy days, that's what we're looking for. And you know you've got your marks for that, so that's great. Next bit says, after 2 days, the man cooks the piece of meat. Cooking the meat reduces the number of bacteria by 90%. Okay, so at 2 days, first of all, at 2 days, your n was equal to, was it 20,000? Let me just check that up above. It was equal to 20,000. So then after 2 days, the man cooks the meat and it reduces the number of bacteria by 90%. So that means you do 0.1, so it's reduced by 90% means it goes down to 10%. So 0.1 times 20,000, and that takes us down to just 2,000. So my n is equal to 2,000. So then after 2 days, that's what it was. It was equal to this. Then he cooks it, so it's now equal to this. He then freezes it. So while the meat is frozen, the bacteria multiply according to the equation. So this new equation, n is equal to n0 e to the qt, where that means q is equal to, and q is equal to p over 100. Now we know what p is from earlier on. P was equal to ln of 2 over 48. So ln of 2 over 48 then divided by 100 again is going to be, the perfect answer is ln of 2 over 48, and is another 00, so 4,800. So that means our equation is this: n0 e to the t times ln of 2 over 4800. Okay, right. It says in the question, how many bacteria are present in the meat when it's removed from the freezer after 2 weeks? After 4 weeks, sorry, after 4 weeks. So 4 weeks, and what is t in this case? T must still be our number of hours, is it? So, yep, t is our number of hours. So we'll say what that is then. 4 weeks is equal to 4 times 24 hours. So you've got 4 times 24, sorry, that's 4 days. And then you've got, so 4 times 24 hours times 7. So that's 4 times 24 is the number of hours in a day. And then, it is not, sorry, 7 times 24 is the number of hours in a week, and then multiplied by 4 would be the number of hours in 4 weeks. Apologies. So 4 times 24 times 7. So I've just done that on the old calculator, and I've got 672. So our t equals 672. Now it says, how many bacteria are present in the meat when it is removed from the freezer after 4 weeks? So we need to put in as well. Remember, when it went into the freezer at this stage after he had cooked it, your N0 was equal to 2000. So let's just fire all of that in. So it is just a substitution thing. It's not an easy one to do, but you can do it on your calculator. 2000 e to the, and it's going to be, I'll do this in a bracket, just 672, sorry, times ln of 2 over 4800. Thankfully, we can do this on our calculator. We were to give our answer to 3 sig figs. I'm going to give my answer to all the figures on the calculator first, and then we'll do this again. So 2000 e to the power of brackets 672 times, and what was it, ln of, sorry, 2000 e to the, in brackets 672 times ln of 2, and then divided by 4800. And if I do that, what I get was 2203.810232, and the 3 sig figs, and that is just going to be 2200 bacteria to 3 sig figs. Okay, let's just read the question, see if that makes sense in case we've gone wrong. How many? So this was while the meat is frozen, the bacteria multiply. So yes, you can see it's multiplied. It's gone up from 2000 up to 2200. So it's multiplied, not by a massive amount, but that seems sensible. Last part of this question says, after defrosting, the bacteria population can again be modelled using the first equation. N is equal to N0 e to the pt. So that was, remember, N is equal to N0 e to the, and it was t times ln of 2 over 48. Remember, it was the original p. The number of bacteria that could cause food poisoning is thought to be 25,000. So this is some time after they've defrosted it. So then we can put that in. It says, how long after defrosting the meat will it be safe to eat? Give your answer as a whole number of days. Okay. So the number of bacteria that could cause food poisoning is thought to be this. Right. Then that means our starting value is actually equal to this thing here. So we'll use the exact one, will we? Just to be a wee bit more precise. So we'll use that one there, the one that's just above. So 2203.810232, and we're going to put it into this thing. So we want to put n equal to 25,000 to see for how long it is safe to eat, because you take it out of the freezer, it's safe to eat for a while, but eventually the number of bacteria is going to get up to this point, and then it's not going to be safe to eat. So we want to put all of those things in. So So we're just going to put 25,000 is equal to 2203.810232. Just use this exact value, e to the, and then t times ln of 2 over 48. And then what I would do, again, you've got a few things happening to your t here. You're multiplying your t by ln of 2 over 48, and then you're doing e to the power of it, and then you're multiplying by this thing. Let's just divide first by this. So 25,000 divided by 2203.810232, and that's going to be equal to e to the t ln of 2 over 48. Just on your calculator, do lns of both sides. So just say, I'll say take ln, and ln, remember, is natural logarithm. Take lns, so you do ln of that right hand side. I'm just going to write that as ln of that. And ln on the left hand side, that's all you've got, ln of the whatever it is. And then on the right hand side, that's just going to give you t times ln of 2 over 48. Now I'm just going to do this on my calculator. Ln of, and what was it, 25000 divided by 2203.810232. And that works out to be, and again I'll use a whole pile of decimal places, it was 2.4, if I could see my calculator, 28688. 28688.039, using far more decimal places than really needed, but that's what is equal to t times ln of 2 over 48, and then just divide across, so you do that horrible thing, and then you're going to divide by your ln of 2 over the 48 to get your t, and that will get your t. So let's just do that answer. It's still on my calculator, so I'm dividing it by my ln of 2. And the 48 as well. So that's ln of 2 over 48, sorry. So my t is equal to 168.18, and we'll go for 185 hours. So that was my t in hours. You're not going to give it I give your answers a whole number of days, so we're just going to divide that by 24, so it's equal to 168.85 over 24. So divide it by 24, and that gives me 7. That's pretty good. That's going to give me 7.00771. So my answer is equal to 7 whole days, and that is us done.